So, good afternoon, everyone, and welcome to this class and this lecture. We are dealing with gravitation, and this is lecture number 2. In the previous lecture, we had dealt with gravitational force, specifically gravitational force between two point masses. We had done a variety of questions where we had found out gravitational force between two point masses, and we had seen Newton laws of gravitation as well. I hope you remember this. Same question will come back after a month or so when we'll start your electrostatics. Right now, we'll just concentrate on questions, and again there will be a repetition. Anyways, now in today's class, what we are going to do is to understand the concept of this gravitational field. Now, this concept of gravitational field is exactly similar to the concept of electrostatic field. In fact, in fact, and I always do things in a systematic way. The last question that we did, the last question that we did, actually we had started the topic there in the last question. And what was the last question that we did? Last question that we did is right now on your screens. What did we find out in this last question? What did we find out in this last question?
Acceleration, sir.
We found out we found
Initial
out what?
acceleration of M2.
We found out the acceleration produced by
Heavier body.
gravitational force between two masses. Now, why is this body of mass M2 experiencing or having this acceleration? It is because of gravitational force created by the mass M1. Now, this acceleration that is produced, this acceleration of the mass M2, as you can see, does not depend on the mass of the body. It depends on the mass of the first body, which is actually causing the acceleration. Now, that gives us a point to start with the next topic, which is known as gravitational field. Now, what is gravitational field? Anyone, any idea? What do you mean by gravitational field? Hmm. Ever heard this term gravitational field?
Yes, sir.
What do you mean by this? If you have heard, what do you mean by this? Gravitational field. What do you mean by gravitational field? So, gravitational field is a space around a mass over which it can experience gravitational force on other masses, or if I talk in general and if I write the heading as gravitational field, if I write the heading as gravitational field is a region in space. Gravitational field is a region in space where what happens?
Where masses experience
Where a
gravity.
body, where a body experiences what?
Gravitational force.
Experiences gravitational force. Experiences gravitational force because of its mass. So, if you find any region where a mass is experiencing force, then you will say that this region has a gravitational field. Now, the next question is who will create this gravitational field? Who creates this gravitational field? In this space, I should not drop this. This is a mass kept here. See, it is falling down. It is experiencing a force. It is experiencing a force because of its mass. Therefore, this region has gravitational field. But who is creating this gravitational field? Who is creating this gravitational field that we all are feeling? Earth
Earth.
is creating this gravitational field, and we are inside the gravitational field of Earth. Moon is also inside the gravitational field of Earth, and that is why it is moving around the Earth. Earth is experiencing the gravitational pull of Sun, and that is why Earth is moving around the Sun. So this gravitational field is created by what?
Earth.
This gravitational field is in fact created by a mass only.
Mass.
So somewhere around there is a mass which creates gravitational field. Now if you bring another mass in that field, that other mass will experience gravitational force, and that is how we explain the concept of gravitational force between the two bodies. So how do I experience, or how do I explain the concept of gravitational force between two bodies? Example, there is one body of mass m1. Everywhere around everywhere around itself, it is creating an area of influence, an area where other bodies, it is creating a field where other bodies, if you place them other bodies, that other body will experience gravitational force. So this mass m1 has created a gravitational field around it. Now if you bring another mass m2 in the gravitational field created by mass m1, this mass m2 will start to experience a force, and that force is the force experienced by 2 because of 1. That is the gravitational force. Do we understand this?
Yes, sir.
This gravitational field, this gravitational field is what type of quantity? Scalar or vector? This gravitational field. Okay, so this is gravitational field. Now, do we understand this?
Yes, sir.
Now, as soon as we understand this concept of gravitational field, we will have to measure this gravitational field, how strong or how weak it is. So now we can devise or derive another term which we can write it as gravitational field intensity. Gravitational field intensity. Or if you don't want to use the term intensity, you can use the same term as gravitational field. Now this gravitational field intensity or intensity of gravitational field or the strength of gravitational field is denoted by, and I am going to denote it by this small letter G vector. This G vector. Why did I denote it by this G? Does this G remind you of something?
Acceleration due to gravity.
Does this G remind you, small G remind you of anything? Huh?
Sir,
Yes?
acceleration due to gravity.
Acceleration due to gravity. Why I am writing gravitational field intensity? The same letter, I could have used any other letter. Now, how do you find the gravitational field intensity or the value of this G vector? So, the gravitational field intensity or the intensity of gravitational field or the magnitude of gravitational field at any point is given by the force experience per unit mass, and I have to make this mass very small. Why I want to make this mass very small? Because if this mass is large, it will create its own gravitational field, and we will not be able to measure the gravitational field. So gravitational field is the gravitational force per unit mass. Do we understand this or this has gone above our head?
Yes, sir.
Saying bye bye, bye bye sir, bye bye, ज़्यादा हो गया. Do we understand this? So,
Yes, sir.
gravitational force per unit mass, whatever gravitational force that mass is experiencing, gravitational force per unit mass is known as gravitational field intensity. Gravitational field intensity. It is a vector quantity. 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 What is the direction of this gravitational field? What is the direction of this gravitational field? G vector. Direction of G vector is same as what? Same as your force or your F vector. It is same as your force or F vector. The interesting thing is, what will be the SI unit? What would be the SI unit of this gravitational field? What will be the SI unit of this gravitational field?
Newton per kg, sir.
Newton per kg. Does this Newton per kg look similar to something?
Acceleration, sir.
This is acceleration. Though it is not written at acceleration, you can also write it as meter per second square. Actually, same as Newton per kg. But when we say gravitational field, we normally write it as Newton per kg, but this is exactly same as meter per second square. Actually, force per unit mass is 4 divided by mass is acceleration. And therefore, this gravitational field is actually the acceleration produced by the gravitational force. And therefore, I have used the word G vector so that we remember whenever we are talking about the gravitational field of Earth, we are talking about acceleration due to gravity. Is as simple as that. Do we understand this or this has gone bye bye? And that is why G vector is used for gravitational field. I am using G vector for gravitational field so that it reminds me that okay, this G vector is acceleration due to gravity. It is nothing but acceleration actually. Do we understand this? So actually what we found out in this question was actually not the acceleration, it was actually the gravitational field produced by M1 and gravitational field produced by M2. This A2 was the gravitational field produced by M2. No, this A2 was the gravitational field produced by M1 on M2, and this A1 was gravitational field produced by M2 on M1. Do we understand this? Basically, we are finding out the gravitational field. The next heading would be gravitational field produced by a point charge. Gravitational field, not point charge. Gravitational field produced by a point mass. Gravitational field produced by a point mass. And how would you find out the gravitational field produced by a point mass? How will you find out the gravitational field produced by a point mass? It will be exactly the same as you will find out the electrostatic field produced by a point charge. How will you find out the gravitational field due to a point mass? Yes, So how would you find out gravitational field due to a point mass? This is a point mass m. You want to find out the gravitational field at this point P. So what do? You put a very small charge. You find out the force on that charge and you divide it. You place a small mass and you find out the force on that mass and you divide that force by the mass of that point mass. Whatever you get will be known as the gravitational field, and it is very easy to understand that the value of gravitational field G will be equal to G into m by r, where r is the distance of the point from the point mass. Do we understand this? Yes or no? Gm by r
Sir.
square. Sorry, Gm by r square. Do we understand this? Yes or no?
Yes, sir.
Now, sometimes you might want to write it in the vector form. So, if you want to write it in the vector form, you can draw a vector from the mass to the point, and then you can write it in the vector form. So, you can draw a vector. As you can see here, this unit vector r is drawn from the body, from the point mass to the point. Then you can write this g vector in the form of vector, and it will be gm by r square multiplied by r unit vector. Do we understand this?
Yes, sir.
Now, this equation only gives you the magnitude of gravitational field. This equation only gives you the magnitude of gravitational field. So I may call it the scalar equation. So I will only get the magnitude of that magnitude of this field. In 99% of the cases, we are going to use this equation only. We will not be using vector equation. Vector equations are only required when a very tough question comes where coordinate of point is given and it is given in 3 dimensions. We are not able to imagine how this field is looking like. Then only we are going to use the vector form. Otherwise, we are always going to use the scalar form. This gm by r square will give you the magnitude of the gravitational field. How you find out the direction of gravitational field? How will you find out the direction of gravitational field? Because when you add magnitude with direction, then only you will get the complete picture about the gravitational field. How will you find out the direction of gravitational field? The direction is drawn here. I would draw this with a green line. This is the direction of gravitational field, G vector. How do you find out the direction of gravitational field? Yes, point mass m creating the gravitational field at this pink point. What is the direction of gravitational field? I've already drawn it to you. You have to just speak. It is directed towards the mass, towards the point mass, along the line joining mass to the point. So I will have to join the mass with the point, with a line, and it is towards the mass. Here in this vector equation, this r unit vector is going like this, but my gravitational field will be towards the mass, so it would be like this. So I should not write it as plus r, I should write it as minus r, because it has to be opposite to the direction of r. This equation gives us both the magnitude and the direction of gravitational field. So I am going to call it the vector equation of gravitational field.
Yes, sir.
The vector equation of gravitational field, because it gives me both the magnitude and the direction of gravitational field. Moving further, we can now get the relation between force experienced by a charge and the gravitational field, and it is very easy to understand that the force experienced by any, I'm always saying charge, it is mass. The force experienced by any mass will be m multiplied by the gravitational field, and that becomes a very important relation, that if you have to find out the force on any mass which is placed in a gravitational field, what you got to do is simple. Find out the value of gravitational field at that point created by whatever charges are there, and you just multiply it by the charge, and you will get the force acting on that, I'm saying charge, force acting on that mass. So you find out the value of gravitational field and multiply it by the mass, you will get the force. That means whatever questions we have done up till now, in which I asked you the force, that question actually were questions of gravitational field. For example, this question. In this question, we had found out the gravitational force on the yellow
Mass.
yellow mass. If you just divide this force by the mass m, or if you remove that mass m from this picture, whatever remains is the gravitational field created by the other three charges, the pink, blue, and the green one, at the position of yellow charge. That means whatever questions we have done up till now can be also called as questions of gravitational field rather than gravitational force. Do we understand this? Yes or no?
Yes, sir.
We don't have to do any further questions. But again, we must also understand the principle of superposition for gravitational field. This principle is valid everywhere. What do you mean by this principle of superposition? Principle of superposition of gravitational field. What do you mean by this principle of superposition of gravitational field? Yes, tell me. Hmm? No one? No one knows? Waiting, I am. I'm waiting for your answers. What is the principle of superposition of gravitational field? Yes.
We did not remember, sir.
Yes?
We did not remember, sir.
Go back and remember. Go back and remember. And you don't have to go very far back. Don't have to go very far back. You just have to go as far back as the last class. You just have to go as far back as the last class. What did we do in the last class? See, that is the problem. But you don't remember. And if you don't remember what happened yesterday, yesterday was 6th of December 2022. And on 6th of December 2022, we did this. And today is 7th of December 2022. And we don't remember the principle of superposition. Sad day. This day would be written in history as the day where we forget everything. So what is the principle of superposition? If you have a point P and more than one point masses M1, M2, M3, and so on are creating their own gravitational fields. G1 vector, G2 vector, G3 vector, and so on. What does the principle of superposition say? The net gravitational field will be the vector sum of gravitational field created by the individual masses. Basically, it says it will be equal to the summation of G1 vector plus G2 vector plus G3 vector plus and so on. This is the principle of superposition of gravitational field, my dear friends. I hope your Gajni status will improve, because that is not going to serve any useful purpose. Any useful purpose here. Okay. Do we understand this?
Yes, sir.
Now, whatever formula we have seen for gravitational field, it is only valid for point masses, or we can say it is also valid for larger body if the distance is very, very large. Do we understand this?
Yes, sir.
You understand this, or
We understand, sir.
okay? Then this question, very difficult question based on this, was in the JEE that I gave. Let's see if you can do justice to this one. Knowing that the mass of the moon is m by 81 and the mass of Earth, and m is the mass of Earth, find the distance of the point where the gravitational field due to Earth and moon cancel each other from the moon. Ta 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 ta. Ta na na na. Na 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 na. Here's the question. And I hope that Gajini fever is down and your student fever is on. Because Gajini fever is of no use, but if the student fever is there and you remember what has been done, you can tell me the answer straight away. You have 2 minutes to show your talents, anyways. Else, I'm always there. 2 minutes you will have. So, how to do this? Anyone, any idea? This is Earth, mass m. This is Moon,
M
mass m by
81.
81. Find the distance of the point where the gravitational field due to Earth and Moon cancel out each other. This is the point. You have to find the distance from the Moon. Will it be closer to Earth or closer to Moon?
Closer to Earth.
Huh?
Closer to Earth, sir.
Closer to Earth. So I have to find out this distance. Let me call it as r, small r. This distance is given as 60 times capital R, where capital R is the radius of the Earth. Yes or no? I have
Yes,
to
sir.
find out the point where the gravitational field is 0. You cannot do this. There must be a very difficult question. Must be a very difficult one. So difficult one that even after doing it once, which we did in the previous class, that was only yesterday. We can't do it again. In the previous class, we had found out the force on a particle to be 0. Now, instead of force, they are asking gravitational field is 0, and we had the formula also ready, but still we can't do it. That means yesterday's class has gone to waste. Yesterday's class is there, down the drain, flushed, and now it is roaming around in the drain somewhere, down the drains of Hyderabad, marching towards getting disposed of in the sea. Exactly the same question, Peter. And the answer is also there. What have you done in the previous class? This distance d from the mass m1 is given by this formula. Same question. Still can't do it. It's such a difficult question. So, if I had to do it with the concept of gravitational field, the gravitational field created by this green body would be going like this. I will call it as G1. The gravitational field created by this pink body will be going like this. G2. G1 should be equal to G2. And I have drawn the diagram wrongly because I have drawn the point closer to Earth. The point will be closer to Moon, not to Earth. And then I had to find out the value of G1 and G2 and get the answer. That simple as that. If this is R, the value of R that I would have got will be D, the distance between the two. Just remembering the formula that we did that day. Just remember the formula that we did that day. Distance between the two is 60 r multiplied by root over that mass from where I have to find out the distance, root over m by 81 divided by root over m plus root over m by 81. That is the answer, my dear friends. And I think you will get 6 hours. That's it. See, this is such a difficult question. Tell me what was the difficulty in that question. If you can tell me what is the difficulty in that question, then I would really appreciate. What was difficult in this question that you could not do? Tell me. What was in this question that you did not understand? Tell me, bacha. Anyone? You could just tell me, sir, this is the point that we did not understand. If I don't understand what you don't understand, what will I teach you? Yes, tell me what you did not understand. You did not understand the formula of G? You did not understand the direction of G? Or you did not understand the question only? What? Tell me. Well, if you don't tell me, what do I do? I will just move on with the next question. And this is the next question. And let's see if we can do this one. Infinite bodies. You can have the same question in the exam, you never know. Infinite bodies, each of mass 3 kg. Mass is 3 kg. Are situated at distance 1 meter, 2 meter, 4 meter, 8 meter, 16, 32, and so on the x-axis. The resultant intensity of gravitational field at the origin is how much? G, 2G, 3G, 4G. And this is not 5G spectrum. This G is a universal gravitational constant. And again, I'll give you 2 minutes to solve this question and come up with the answer. And I know you can do this. There's nothing in this thing that I have not told you that you cannot do. So I'll give you 2 minutes. The diagram is not a part of the question, but I am giving you the diagram as a hint. I hope when you have a look at the diagram, you would be able to solve the question quickly because I can't spend so much of time waiting for your answer. So giving you the diagram as a hint so that you can find out the answer quickly. So again, I'll wait for 2 minutes exactly, and I hope that I get an answer by that time. So how do we do this? It is quite simple. If I call this as the green mass, the gravitational field created by the green mass, G1 would be going like this at that point. No, it is towards. I'm not drawing it at a point because it will become crumbled up. The gravitational field due to this blue body will be directed like this, G2. The gravitational field due to this pink body will be directed like this, G3. Yes or no?
Yes.
All the gravitational fields are coming in the same direction. Do we understand this?
Yes.
Gravitational field due to this fourth body will be going like this. So the net gravitational field, vectorly, I can just write gravitational field net will be G1 vector plus G2 vector, so on up till infinity. Yes or no? There are infinite number of charges. And all of them are in the same direction. Yes or no?
Yes, sir.
You can call this direction as positive. The value of G1 is G into M divided by 1 square, where M is 3 kg. Yes or no?
Mm.
Plus G into M by 2 square plus G into M by 4 square plus up till infinity. What does this become? This becomes an infinite GP. Yes or no?
Yes, sir.
with the common ratio as 1 by 4,
1
yes
by
or
4.
no?
Yes, sir.
So the ratio, so the value of G net gravitational field becomes what? Gm 1 upon 1 minus 1 by 4, yes or no?
Yes, sir.
And the value of M is 3 kgs. So if you add them, the value of G net becomes 4 times G, and that is the answer that we are looking at. Do we understand this?
Yes, sir.
Everyone got this or no?
Yes, sir, we got it.
Okay, chalo. Well begin is half done. So this is one. Let me make one more question, and I hope that you can do that one as well, so that I have the confidence that you have understood the concept and I can just move forward. Question number 3 comes up now, and here I have two masses M and M, and this is an equilateral triangle of side length A. This is the point A. You have to tell me what is the gravitational field at this point A. This is an equilateral triangle of side length A. I'll give you 2 minutes to do this. It's a very simple question. Can be done very simply. 2 minutes you have.
Root 3 GM.
Yes, so do we have an answer?
Root 3 GM by A square, sir.
Root 3 gm by x square. I think that is
A
good.
square, sir. A square.
Root 3 gm by
A square.
a square looks good. The gravitational field be created by this mass would be going like this. Let me call this as G. Gravitational field created by this mass will also go like this. Both the gravitational field are equal in magnitude, yes or no?
Yes, sir.
And the angle between these two gravitational fields is 60 degrees.
60
You
degrees.
can straight away apply that formula of two vectors. So the net gravitational field G net will be equal to under root of G square
G square
plus
plus
G square plus 2 times G
G
square
square
cos 60 is half,
cos
yes or
60.
no?
Yes, sir.
So it will be root 3 times of G, and the value of this G is G into M by A square. So the answer is root 3 times GM by A square. Do we understand this?
Yes, sir.
Very good. Now remember, this was gravitational field created by a point mass only. Now, in the question that we are going to encounter, we are not going to get questions only on point mass. Basically, in this chapter, we are most likely going to get questions where we will be dealing with planets and stars and suns, and they would be spherical in shape. So we are more likely to deal with the gravitational field of spheres and shells. So now I will give you the formula for gravitational field created by these bodies, 3 or 4 of these bodies, not all of them, because the rest of the bodies we will be dealing in chapter on electrostatics, and then you can just understand their formula. So I'm just going to give you the formula which are required in this chapter and this chapter only. Do we understand this? Yes or no?
Yes, sir.
The first formula is gravitational field due to a solid sphere. Remember, sphere is always solid. So someone says sphere, you must understand that it is a solid sphere. Do we understand this? Sphere is always solid. There is no liquid sphere. Okay. You understand what I mean by
Yes,
liquid
sir.
sphere? Sphere is always solid. Okay, so this is the gravitational field created by a sphere due to a uniform solid sphere. Gravitational field inside the sphere, no, sorry, outside the sphere, where distance is more than the radius, it is same as the field created by a point charge. Do we see this? A point mass. Do you see this? Gm by r square.
Yes, sir.
The same as the field created by a point mass because it behaves like a point mass. On the surface, You put the value of small r as capital R and you get the answer as gm by r square. The most interesting formula is the gravitational field inside the sphere, and the formula is gm into small r divided by r cube, and this is the graph which shows how the gravitational field is varying. Remember, inside the sphere it is directly proportional. Remember, the maximum value of gravitational field is on the surface. Do we understand this?
Yes, sir.
The maximum value of gravitational field is on the surface. After that, it is varying, and at infinity it becomes zero. This is the formula for gravitational field due to a solid sphere. Remember, there is no liquid sphere. A sphere is always solid. This is the first formula that you must remember. I hope you are noting it down.
Yes, sir.
At the same time, I will give you the formula for spherical shell. Do you understand what is a spherical shell? A spherical shell is something that you can also sometimes call as hollow sphere. That means it only has outer covering and inside it is empty. You can call it, the best name is spherical shell. The best name is spherical shell, but you can also call it hollow sphere. If you're calling one as a solid sphere, you can call the other one as the hollow sphere. This is the formula for hollow sphere. Inside the hollow sphere, there is no mass. So the gravitational field is, they've written this it as I. You must not write it as I, you must write it as G. Do we understand?
Yes, sir.
Not every book follows my logic. They call it as I, or some people also call it as EG or IG. Okay, so inside the sphere, the gravitational field is zero, that you can see. Whether it is on the surface or any point outside beta, the formula remains same. I hope you are getting this. Yes or no? No,
Yes,
yes.
sir.
These are out of this, in 99 or 100% of cases, you will be getting case number one, because everything, a planet is always solid sphere. It's not hollow from inside. So the most important formulae are formulae for solid sphere. Shell, hardly you will find any question, and the rest are more rare. The rest are more rare, but I will just give you the formula because I have seen a couple of questions on this. I've also seen a couple of questions on point line masses, which we'll discuss in the electrostatic chapter, because we will have more time over there. Have you noted down these two formulae?
Yes, sir.
Then the third formula comes is a formula for a ring. Remember, in the previous two examples, we had not written the direction of gravitational field. The direction of gravitational field is always towards the center. Do we understand this?
Yes, sir.
Here also, the third case is the case of a ring. The radius of the ring is given as r. The radius of the ring is given as a, and the distance of the point is given as r. The gravitational field at any point on the axis, remember the direction is always towards the center of
Towards
the
the
ring,
center.
and on the center the gravitational field is zero. Remember this. I had seen a question in JEE Advanced weight of paper, not JEE Advanced, I think it was in Olympiad, that they had a ring shape, some Olympiad, some international Olympiad. I had seen that question. It was a ring shaped planet they had put a question. So for that, the ring wala thing might be useful. Anyways, we will encountering all these formulae in details in electrostatic, so you don't have to worry. All these formulas will be covered in electrostatic once again. Don't have to worry. The next one is gravitational field created by a disk. I have also seen a question of uh, disk shaped planet or a star they had created. And again, the formula looks like this. The gravitational field is directed towards the center of the disk. At any point on the axis of the disk, you can write it like this: 2gm by a square into 1 minus cos theta. This cos theta is the semi-vertex angle of the cone. I hope you understand that rotation. If I take this as a cone, you understand? I can
Yes.
think of this as a cone. Yes or no?
Yes, sir.
So this theta becomes the semi-vertex angle of the cone. Yes or no?
Yes, sir.
Semi-vertex angle theta. So these are the 2 or 3 important formulae that we might have to use. Remember, outside the sphere, they are all acting as point masses, and those are the questions which are more likely to come. Have you noted this down?
1 minute, sir.
Rally move its questions.
Yes, sir.
Okay, this is the next one. This is from one of the previous year IITs. The magnitudes of gravitational field at a distance of r1 and r2 from the center of a uniform sphere of radius r and mass m is f1 and f2. So they are calling it as f1 and f2, not g1 and g2. Then that's this is the way questions are framed in a JEE. They will try to confuse you in whatever ways they can. If you are smart enough, you will not get confused. So what is the answer for this one? And it is a multiple choice correct. So it can have more than one correct options. It's multiple choice. Yes. What is the answer? No one?
1 minute.
I've just now given you the formula, beta. Just now. So the answer is yes. I'm still giving you a chance. Option A and option B. Why
Yes,
option
sir.
A? Inside the sphere, gravitational field is directly proportional to R. So option A talks about gravitational field inside. It is directly proportional to R. So G1 by G2 or F1 by F2 in this case will be equal to R1 by R2. Outside the sphere, which is given in this case, the gravitational field is inversely proportional to R square. So G1 by G2 will be equal to R2 square by R1 square. Is it so difficult to understand? Huh?
Oh, sir.
So difficult? It is not so difficult. Anyways, do we understand the answer after knowing the answer or no?
Yes, sir.
But we should understand it before understanding the answer, before listening to the answer. That is why we are having this class. Anyways, I always feel that students are like cash vouchers. You can redeem them. So this is a chance for redemption of your cash vouchers. Question number 6 or 7, whatever it is. Two concentric shells of mass m1 and m2 are having radii r1 and r2. Which of the following is the correct expression for gravitational field on the mass m? Small mass m is hanging somewhere. What is the value of gravitational field on the mass m? And I wait your answers patiently. I have a lot of patience, but my patience is wearing out. Yes, my dear friends. Do we have anything that looks like an answer? Yes, A, B, C, D, which is the correct option, my dear friends. If I look at option 1, R is smaller than R1, so it is inside the smaller shell. Can there be gravitational field there?
Sir.
Yes or no?
No, sir.
No, sir. So this is wrong, sir. Then R is smaller than R2. It could be anywhere. We don't know where. So therefore, this is also wrong. Coming on to third one. Third one is between R1 and R2. Between R1 and R2, can M2 create gravitational field? In this space, can...
No, sir.
No, sir. So this is wrong, sir. So what is left, sir, is has to be correct, sir. Between R1 and R2, only one mass can create field. That is M1. Because for it is outside. For M1, it is outside. For M2, it is inside. Do we understand this?
Yes, sir.
So the correct option has to be option D, my dear friends. I hope we have understood this. Yes or no? No, yes.
We understood, sir.
Huh? Or this I go on about saying bye bye. Bye bye. Bye bye. Huh?
We understood, sir.
Pakka?
Pakka, sir.
Now we noted this down. Shall we move on to the next question?
Yes, sir.
Well, then this one, sir. Question number 7 or 8 or whatever it is. A spherical shell. Please look at the language of the question. A spherical shell is cut into two parts along a chord. I've cut it. P is a point on the plane of the chord. The gravitational field at point P due to the upper part, which is not equal, is I1, and due to the lower part is I2. What is the relation among them? Which one is more, which is less? I is more, or I1 or G1, gravitational field G1 is more than G2. Option number 2, G1 is less than G2. Option number 3, G1 is equal to G2. No relation. Which is the correct option? Nah?
C, sir.
Yes, beta?
C, sir.
C, sir. Why, sir? Akkar bakkar bombe bo. Why it is C?
Sir, when the sphere is joined, so the gravitational field at P is 0. So it is divided. So the gravitational field net at that is 0. So it should be equal I1 and I2.
Equal in magnitude but opposite in direction, then only it
Yes,
will
sir.
cancel out. That is the correct logic and that is the correct answer. As you can see, boys are like, students are like cash vouchers. Sometimes they might not get redeemed, but if you put the code correctly, the redemption is always there and you get a free voucher, 50 rupees. Comes the next one. Can you redeem yourself further? Can a 50 rupee voucher become a 200 rupee one? This is the question. If you do it, you become a 200 rupee voucher. Cashback. A uniform ring of mass m is lying at a distance of 1.73a. Actually, it should be root 3a. So root 3a from the center of a sphere of mass m just above the sphere, where a is the small radius of the ring as well as that of the sphere. So the radius of them are very small. What is the gravitational force exerted? I'll give you 2 minutes to solve this. This is more a conceptual thing than anything else. I was about to tell you that this question can come in your JEE, and I'm very surprised to see just now I opened it up, your previous paper, and this is what I see. Exact copy. This is in the year 2021, I think. Exact copy. The moral of the story is what is the moral of the story? That if you just do the question in the class, it would be more than enough for you to clear any exam. Just do the question in the class. This is the question from your JEE paper. And as I said, the question is more conceptual rather than anything. Now, what you have to understand, can talk about any of the question. What you have to understand here in any of the question is which force you can find out. Now, whatever forces they are going to exert on each other are going to be equal and opposite. Yes or no?
Yes, sir.
So you can either find out force exerted by a sphere on the ring or ring on the sphere. Which is the one that you're going to find out? Remember, sphere is symmetrical from always, from everywhere. Yes or no? So it
Yes,
is
sir.
always easier to find out the force on the sphere in this case rather than the ring, because ring, the mass is like this. How will you find out the force on the force becomes very difficult to find out. But if you can find out the gravitational field at the center of the sphere created by the ring, and how will you find out? You have to use the formula for the ring. What was the formula for the gravitational field created by the ring? G
G.
m into x. X
M.
is root 3a
Yes, sir.
divided by a
Divided
square
by A
plus x
square.
square raised to the power 3 by 2.
3
So
by
that will
2.
become a square plus root 3a का whole square 4a square 4a square का root is 2a 2a का cube is 8a cube. Yes or no?
Yes, sir.
That is your answer. That is the gravitational field. Now you just multiply it by the mass of the sphere and you end up with your answer. And I think your answer would be D in this case. Yes or no?
Yes, sir.
Similar to what your answer would be here. Now, can you tell me what is going to be your answer in this case?
Um,
Yes? Quick, you have got 1 minute. Answer in this case is
1 minute, sir. 1 minute. D, sir. Fourth option.
fourth option. So if you just concentrate enough, you should be able to solve any question that comes in this category. So we will try to do that. I will put more questions and we'll try to do all types of question that have come, and I will show you questions that we have already done in the class. They have already come in the exam, but that does not mean that they will not come again. They will come again because these are the type of question that always come. So we will continue our discussion in the next class on gravitation. We will do more questions, and the more the number of questions you do, the better are your chances that a similar question will come. So take care. God bless all of you. I'll see you in the next class tomorrow. Bye bye.
Thank you, sir.
Bye, bacha.